Almost there. Oops. All right, I think we are ready. Okay, so it looks like it's working. And this meeting is being live streamed. Okay, excellent, got it. Okay, so hello everyone. My name is Mike. I work at the Blue Island Public Library here. It is August 12th, 2021. It is 6:02. And today's class is Raspberry Pi. So I'm going to be talking about that. I have a presentation for you, a couple of slides. Mostly I'll be trying to just show equipment. And I guess what I will do here is go ahead and share my screen. Share screen. Okay, so, all right. Remove some of this stuff that we don't need. And I have something here. It's the wrong folder. My class. I ran this class last year, and so it's mostly going to be the same thing. Hopefully, I'll be able to make it more exciting. So Raspberry Pi, so if anybody doesn't know what Raspberry Pi is, it's a little miniaturized computer. Basically, it looks like the picture that you see there. The best explanation, excuse me, that I have read was credit card size computer. So anything that a computer can do, mostly for the most part, like Raspberry Pi can do. Obviously, you're not going to be doing like graphic editing and video editing and things like that. But you can do, from input output to, and I'll talk about all the different peripherals in a moment, to like using it as a workstation, as a computer. In fact, yes. So those are the basics of what this is. So I'll start with kind of by going over the different types of these and what they can be used for. So quickly, to kind of get your mind going a little bit for this. So what they can be used for is different things. When I say different things, it's a very blanket term, but you can attach buttons to these, you can attach lights to these, you can attach sound to these, you can control devices. They use it for robotics and things like that. You can put it in your home and have it act as like a file server. You can connect it to your television and have it stream media and things like that from a library or streaming. You can, if in your home, you can have it probably configured to control lighting and things like that. You can do all kinds of things, different applications. You can do, like we have a photo booth application here. You can run like security cameras attached to these. You can run have some kind of sound play every once in a while as like an announcement type of thing. Door counter applications, you can hook up light sensors, all kinds of stuff. So we'll go over that shortly. So the first thing I'm going to do is show the different types of Pis that there are. So Raspberry Pi models. The one I have in my hand is a Raspberry Pi 2. They make 4 now, I think, is the most recent one they have. So they're made by a company out of Europe, and they make everything you see here. So they started with Raspberry Pi 1, and then there's A, and there was B, and then 2, 3, 4, and now they have 0. They kind of stick to their price point for these is usually $35. It's kind of it's a tinkering toy kind of thing, although it has some feasible like office type applications as well. So you've got all these, and they make them with different hardware, you can spend a little more and get like, 8 gigs of RAM or something on one of them more. But basically, probably should. All right, so this Pico is new, but basically you can do almost all the same things with a lot of them. So Raspberry Pi 234, $35, but you kind of add a couple parts with them as well. And Raspberry Pi Zero, which is relatively new, which are these. This is $5, and this other one with a W on it is wireless. That's $10. So you can easily, get like a small, USB wireless thing attached to it, but it's easier to just get built in. I think is easier. So those are the models. Now the parts. Here's a good diagram here. In fact, I may even make this full screen. Maybe I'll just play the show for a second here. Oops. Sorry, you can see how much I use PowerPoint. Probably what we'll do is, now I think you can probably see. Let's see, let me just save this. Bear with me for just a second, and let's see. Okay, is there a full screen? This time. All right. Hopefully you can see that, but the more interesting part is this part with the board here. So as you can see, and I have the same thing in my hand, you have a giant processor right here, another processor for probably graphic or some, actually it's for USB and Ethernet control. And here is, but they run off of SD cards, which you can buy anywhere. This is a display port. You can connect it to, this is kind of an older style display port, which we don't really need to go into detail just this yet, because they have also HDMI, which is this large piece right here, which I think everybody has HDMI in their television at home or monitor. Take micro USB, which you can find everywhere. Powers everything, all kinds of gadgets, all the, like most of the Android, Samsung phones take micro USBs everywhere. There's a camera port for various different camera applications, which you can talk about, and then a audio port, so you can connect just sound out. Of course, the LAN port, of course, there's wireless built in, and 4 USB ports usually. Some of the models have less. You could just as easily put a hub in there usually, unless you're drawing very large amounts of current. And finally, the more interesting is all these pins at the top, which they call GPIO, which if memory serves is general purpose input output. This is kind of the cooler part of Pi, at least, because you can connect a lot of different sensors. Sensors being, could be a temperature sensor, it could be just a push button switch, could be some kind of infrared thing, could be, you can have output thing, you can have maybe tiny motors attached to it, you can have LED lights attached to it, you can have all kinds of different things. More on that soon. So let's go back and diagram we kind of talked about. Okay, so on this board, before we get into how we connect all that stuff and how that works, basically you're running an operating system on it. Thus, when I say credit card size computer, you're running a whole operating system on this, on a SD card, micro SD card. And the default, not default, but the recommended one that they use is now something called Raspberry Pi OS. And you can get it from Raspberry Pi website. You can actually get a couple different operating systems, but I think that is the one that is being recommended now. It used to be something called Raspbian, which is basically Raspberry Pi and Debian. So I'm going to click on software and see what is here. I think. Oh, Raspberry Pi OS. Okay. So this is on their website. Basically, you can just download an image. There's actually a more friendly installer, but I don't know if we have time to. Yeah, so actually all this stuff can go on Raspberry Pi. So the recommended one is this Raspberry Pi OS. And from there, we'll do these one at a time. So first they have Raspberry Pi OS with desktop and recommended software. Basically the operating system with a whole bunch of stuff. Raspberry Pi OS with desktop, which is probably what I'm going to be using here, which is basically a desktop environment, which I'll show you in just, actually I can show you that right now, in just a moment. And then there's Raspberry Pi OS Lite. I haven't used, I assume it's probably just a command line thing, and that's fine. Raspberry Pi desktop. Yeah, so there's Debian Buster in this case. So the version of Debian that can fit on Raspberry Pi. If you're not familiar with those, don't worry about it. Debian is just it's a version of Linux. And all these, this is like LibreElect is for the, usually used with Kodi for media streaming. This is like when you want to hook something up to your television. Ubuntu, Flavor Linux, it's been around for like 15 years, probably longer. Pi is like an old video game thing. And TLXOS, I'm not familiar with that. Symlytics, okay, oh, ThinClient. Okay, we don't need to worry about that. And this is probably what the extra software is that we saw above, Mathematica and Wolfram, extra software that we don't need at this point in time. Now, what I've done earlier was download this middle one, which is kind of like the, I must want to say like this is small, medium, and heavy. Just because it has, this is like a 3 gig download. So I kind of pre-downloaded this file, and it's 1 gig. So, and I'm over the wireless, so I'm not going to do it again right now. But basically, I downloaded that file, and I got that here, which maybe I'll even just delete this. So they come as a zip file, and I don't know why this computer has WinRAR on it, but that's fine. You just need to extract that. In our case, even if you don't have a utility for it, if you're using Windows or something, it comes with something that usually you can do open with. Windows can do it. But basically just expand the file and you'll get a folder in it. They come, in this case, they come as an image file. There's another, it's another installer that they have. I'm not sure. There was, I don't remember seeing something earlier. But this is just an example. Imager. Yeah, so they have this other Raspberry Pi Imager, which I think is an easier way to download software onto the Pi. Maybe do that later if there's time. But the crux of it here is you can just get an image. And in our case, this image needs to be written to a SD card. So let me see here. Let me put myself back on for a second. I think that is right. So SD cards, you can get them everywhere. Mine came in a little container like this. I got it off Amazon. These are like, I don't know, $5 or something. Less to get smaller ones. And I have a couple of them. Here's one here that just, that's what I don't know what was on it. So my method was to physically tape it to a piece of paper with written what was on it. I shouldn't tape it, huh? All right, so apparently we have really strong tape at the library. There we go. All right, so runs off this micro SD card. You can find them anywhere. Basically what happens is on Raspberry Pi 2, 3, 4, Raspberry Pi 0, whatever. It goes in a little port in the back. I don't know if you can see this, but it says, it's not even labeled. Oh, yes it is. says micro SD card. Hopefully you can see that and it's not in reverse. And now the older ones, so this is Raspberry Pi 2, goes in here like such. And this one is like a click lock. You push it in and it clicks into place. The newer ones don't actually have that. It's just kind of held in place by friction. But anyway, we want to put the image on here and then insert it into the Pi. So I'm going to fast forward here because it takes a while to, at least it took a while for this laptop to burn that image. I'll still show you what I did though. So in this case, I believe on their website, they recommend using another software called Etcher. Basically, you just need something that can write to an SD card. In my case, I haven't done this in a while. So I'm using something called Win32 Disk Imager. And that's just something you can get anywhere. You can get it from SourceForge. And you just download it and install it and it's there and it's great. So I'll show you the way that software works. And hopefully this is not too boring. We'll get to other things soon, I hope. So this is the interface for it. And basically you just pick the file that you wanted to burn. In this case, I have a folder and this big IMG file. And you tell it which drive letter to connect to. I didn't actually connect. Let's see. Let me stop this for a second. So I'm gonna take this card out again. And in my case, one I happened to buy came with a SD, like standard size SD adapter. A lot of people have a laptop that has a port for this, goes in the side. This particular laptop, it's kind of old, so it doesn't actually have it. So I have to use an adapter. So normally people could probably just put this in here and then insert this into their computer and it shows up as a drive letter. Everything's great. If you have an old computer like I'm using right now, you can use an adapter for USB, in which case these are like, I don't know, a couple bucks, I don't know, $5 or $10 on Amazon. Basically, you put the card in here, and then it's USB on the other side and it goes into your computer. Bring up actually, let me share my screen again. All right, so I get a little message here that says something's wrong, but that's right, we're not gonna worry about that. And so basically, here's what shows up. It gives me a drive letter F. In this case, I kind of have something on it already. That's fine, it may show up as blank or something. But the point is, when we go to here, it'll show up as a drive letter, and you're just gonna be writing the image to the drive letter, which is essentially the card. So you click write, and it will do it. I'm not gonna do that now because it takes probably at least 5 minutes. So I'm gonna fast forward to pretending that we are done because I actually have done this earlier. Not waste everyone's time. And I have that. Should be interesting. We go back over here for a second. Grab this. All right. So I have one here. All right. Sorry, it's not in there yet. It's actually. So since I have preloaded this software on here, I have an SD card that has it. It's out of here. In the present. All right. So after that thing writes, it'll be on the card. Here's another one. It's on the card. I just did it earlier. Something simple. I'm going to input this here, connect it, and now we just need to power the sign on and connect it to a screen or something, which I happen to have behind me. Now we have to talk about power so we know what we're talking about. I mentioned earlier, this thing takes micro USB, which is right here. So you can get just a generic shape. What's supposed to happen is you can get an adapter like this is particularly made for Raspberry Pi. This is actually made for Pi Zero, but it would work fine. Wall side and micro USB on the other side. And basically you just need 5 volts and at least enough amps to work with. Now, question, could you connect the Pi to a laptop to work as a screen? That is an excellent question. I don't know. We'll try that in a moment. Trying to think. Yeah, I think because so this particular laptop has HDMI on it. Well, it has DisplayPort because HDMI could do. I think we could do. Well, see, I don't know if it'll work. We'll try it. I think this HDMI port is only as an output, and the one that's typically on your laptop is only as an output as well, so you can connect to your screen. But we'll try it in just a few minutes. So, like I said, we're going to power this thing. This thing, for example, I don't know if you will be able to read that with the camera that I have, but this says 5 volts. So they're always going to be 5 volts. And this is actually 2.5 milliamps, which is good. You can get by with like 1 and it'll still work if you don't connect a lot of things to it. But basically, you can use, in the case here, I'm just using like you would buy with like an Android or Samsung cell phone cable like this and adapter like this, which you buy like there's a million of these on Amazon. Connect this to here and plug it in. So that's that, and I'm also going to connect the HDMI, which is going to be the screen, and hopefully it'll work. So this goes to my screen. This is HDMI. This is sort of our first run thing here. So I am connecting the power here. Incidentally, we kind of generally say to, if you're going to be turning on and turning off a lot, leave this side plugged in because this is kind of like a sensitive port, whereas this is like a big standardized, ruggedized thing. So I'm going to plug this in. Yeah, hopefully we could see the monitor here. So that more. All right. So there we go. So here's the other end of this, and this will be the first run for this. So it's going to do a couple of things that may be interesting, hopefully. All right, so I plugged it in, and hopefully, okay. So we get, this is like the splash screen, that little rainbow thing, and it is working on something. Okay, so it's resizing the file system. Basically, the operating system doesn't know what size SD card we put in there, so it resizes it to fill up the entire thing. That's all that is. So it reboots again, it just resizes the file system. Incidentally, this yellow lightning bolt up here is, it was just there. Sort of a problem with voltage. So I could have a bad power supply or a cable or something. There it is again. I don't know if anybody's able to see that. That becomes a problem if it stays on all the time, or can become a problem. Basically, it's saying that it's under voltage. And since we're running Linux, you're going to see a lot of lines and stuff that's going on in the background. Here, we should see, I want to say Raspbian, but the Raspberry Pi OS desktop environment. So cool. So there's that. So now we have a thing that we can work with. Now it's possible to, we have USB on this. We could connect the keyboard and mouse to this if we want to. And there's all kinds of things on here in the start menu, like you would find on any computer. There's, you can just go to the web. You can connect to the wireless here and go to the web and browse YouTube or something like that. I don't know how heavy a video quality we can get, but you can at least just watch standard definition videos on YouTube. At least the Pi is intelligent enough for that. So that's kind of how we get something going here. Now, the extension for this is later on, we're going to want to run some code and things to kind of interact with all the pins in here, do something cool and useful. I don't know how much time we'll have for that, but we will see. Now, our question was, can we connect the Pi to a laptop and use the laptop screen? That is an excellent question. So what I'm going to do here is I'm just going to pull the plug on our thing. It turns off. Probably been taught not to do that, but it's pretty, I mean, it's Linux underneath, so it usually survives. This. And let's see, I need to use my laptop. So let's see how interesting this gets. Okay. Now I need to get an HDMI cable, which I have. Luckily, I have one right here. So hold on. Aha. So again, generic HDMI cable. There's sort of another thing you can do with this other display port, but I think HDMI is a lot easier to deal with. Right, so I'm going to connect this to, my case, I have to use a display port adapter. But we're just going to turn it on and see what happens. And hopefully nothing happens to our Zoom. I don't know if anything will come up on my screen or not. Probably won't be able to see it, so you just have to take my word for it. It's turning on, and I do not believe that that works the way we had hoped. No. So the answer to that is sorry, I don't think it works that way. I think you need to get a screen or spare monitor or use your television or something like that. That would be cool though. So I'm going to unplug this. I'm going to leave this guy over here for a minute. See this. All right. So let's go back to our presentation. Let's see. All right, we were doing. Okay, we kind of talked about the different parts and stuff already, the ports, I should say. Now you can also get, all right, so let's skip to, I think I have a page. So this page I think was very good. This was a kit on Amazon. You can buy all these parts individually, but this showed a lot of what is possible. So here, there was this kit that had all these different sensors on it. And say, okay, sensors, what does that mean? What kind of sensors? Would be a good question. There is a list, if I recall. There we go, okay. So basically all this stuff can be connected to Raspberry Pi in a certain manner. So you can, so the easiest is like an LED light. And that's kind of just a signal that something is happening. LEDs you can get everywhere. Every electronics shop probably sells them. It's like yeah, little thing with two little tiny LED light with two pieces of metal hanging off of it. RGB LED, so you can get some that change color, and usually you can use the Pi to change the color on them. And so, okay, just an LED light, but you could expand that to work with something much cooler. Relay module, laser emitter. So yeah, laser emitter, you know, could be sort of like a photo, like a laser emitter could be like you're emitting a beam and waiting for a return. And as soon as something breaks the beam, think of like a door counter or something. So as soon as something breaks the beam, you could say, run some code, make something happen. So this could be like, I don't know, I think I saw one where it was like a room alarm, where it was like if somebody opened the door, it would break the laser line. And then you could say, all right, play a sound through some speakers or send an email or do something like that. So that's cool. Buttons. Buttons are cool. They're just basically there to accept some input. And I had some buttons. I have one of my buttons, but I can show some of those later. They're basically just a big button. You can get like the big Raspberry Pi. So if you wanted to make like some kind of interactive display or something like that, you could say, here's an example of like a very small like tactile button. You could see like, okay, 41 cents. You can buy like a bin of like a bag of like 100 of those for like $5. You can get some. This one has an LED light built into it, so it lights up. Or you can get like a huge button. It's just like picture like those easy buttons, like those Staples things that are like really big. And that would be just, you know, if you had like I'd probably take the headphones off at this point. No, or maybe I'll leave them on. Yeah, so if you had like a display, like say like a museum type of thing where you wanted somebody to go up and hit a button and you wanted it to then play a sound and light something up and like give you some information, that would be cool. Or if you just wanted to like hit a button and every time you hit the button, it sends an email to somewhere, like, you know, that somebody is there, some kind of doorbell type of system, all kinds of different things. Input button is just there to make something happen when there's a human there. Tilt switch, maybe some kind of pinball machine or something, vibration switch, infrared receiver. We kind of talked about with the laser emitter. Those probably would go hand in hand. Buzzer. So not only can you connect, Raspberry Pis usually have a audio port, like it's almost like just like the headphone port on your laptop or something. But you can also connect what's called a piezo buzzer, which is basically, this is one. You can see that. Basically, connect two wires to it, and it kind of pulses at a certain range, and it makes a bzz, makes a buzzing noise. That's all. Here's an example of. I'm going through my parts here, and I just found a little button. So here's, I don't know if you can see, stop sharing for a second. All right, so here's an example of they call it a tactile button because it makes this like clicking noise and you can feel that it's not a soft touch button or anything. So this basically, again, all this stuff connects to Raspberry Pi GPIO here. So now you're thinking, okay, how are you going to get LED here? There's another example. Light. So here's an example of an LED light. It's got two pieces of metal on it, and here's an example of a button. So this is, you know, an output thing because it would either light up when we wanted to or not light up. And here's an example of a button which somebody would press the button when we got close, when they wanted something to happen. These, the point of these is they're going to connect directly to the pins on the Raspberry Pi. Now you're probably thinking, okay, how in the world does this, you know, connect to this? So you just need a piece of metal to go there. So most of the time they make some kits that kind of look like this, which is a bunch of jumper wires. And pull one out. Let's see, here's one that's already out. How about this? So here is actually, here's a perfect example because here's a wire that is basically male on one side, and then the other side is female. And so in this case, the female side can connect to the Pi, just slips over one of the pegs here. See that? And the other side, in this case, one thing we could do is, this is all just metal. I mean, you could just twist this around so that they're touching each other. You could put a piece of electrical wire on it. You can get different kinds of connectors. And the same with this. This is kind of confusing because this is kind of like, the way this works is it's kind of like two staples. Like, these are connected and these are connected. But basically you can connect it, as long as all the metal is touching, you can connect this, even though it looks kind of weird in the back, to the pins. There's a way to do it. Just the metal has to be touching. It might be a series of different kinds of wires like that, or you might just have, you could even do like those, let's see, those like gator clips that just is a piece of metal easy to get everywhere as well. Basically, like these are just, this has like a little shield on it. Let me take this off so you can actually see it. Yeah, just like clips like these. Just to open it and it clips on. So if you wanted to, I mean, you could just do, clip that on like that, and that should work totally fine. And then the other side would go to the ground. It's kind of like almost needs another. Let's go do like a whole class just on that. But basically, the short version of this would be like to just say like light up an LED or something. These pins are all special purpose. In other words, let me share my screen again. On the actual Pi, I think I had a picture. Here we go. Yeah, so I'm looking at this top part. I can rotate this. Yeah, so notice how these all have different names on them. So these like, let's start from the top right possibly. So these one that say 5 volts on them basically means that 5 volts is running through that all the time. It's just always on, it's always power. Next ones are grounds. There's a bunch of them around, just, there's a whole bunch of grounds. So to make, say, an LED light go on, basically you would just take LED, connect the longer side is the positive side. I don't know if you can see that, but there's actually one wire on an LED, usually on an LED, one of the wires is slightly longer than the other one. So you connect this with either the gator clip or the, probably be easier with the like the jumper cable thing. In fact, a female to female would probably be perfect. Female, male to male. Male to female, here's a really short one that I'll just use. I use the longer ones that came in our kit, but I don't need to. So a cable like this, just as a quick example, and this isn't going to work because the Pi that I'm actually demonstrating with doesn't work. I could use one of the, if there's time at the end, we'll just do it, but I'm just showing you as an example. So basically, plug this in here, and then plug this into, the hot one, which I think is the corner, and then do same. Actually, the diagram is usually, hopefully this is the right, usually so top right one is 5 volts all the time. And then we will plug another cable that goes from, this fell off, but the short one back into any of them that say ground, and the light should light up. I'm not sure if that's interesting or not to actually see it in action. You take my word for it that it would light up. Now, the other part here is back to this diagram. Some of these say GPIO and then a number. Now, those are all programmable ports. In other words, we can say whether there's power going to it or not with code. So we can write a program that says, turn on this particular port, this pin, turn it on and turn it off periodically, or I don't want to go too far ahead here, but basically the ones that say GPIO can be configured in a manner that we control. So we could do the same thing instead of connecting. So in other words, if we connect it to the 5 volts and a ground, the light will just be on all the time and that's life. If we connect it to GPIO, some number and a ground, then we can control it with some code, which I can show. I don't know if there's sort of like, it's kind of a whole world. You can almost do a class on every single thing. And the same for like this button switch. like these GPIOs can not only be an output for turning power off and on, they can be an input for something such as a button. So you could take a number of these ports and say connect a switch like this to say these two, 12 and 14, and then connect an LED light to say these two, say number 6, number 8, and then we can use code to say like, okay, whenever we click this button, the light goes on. If we click it again, the light goes off. So you're demonstrating you can do input and output with it, and then the sky's the limit at that point, because you've already decided you can wait for an interaction and then do something, and you can turn something. And in this case, okay, you're just clicking a button and a light goes on or off, which is kind of boring, but think of more things you could do. Think of like when you go to a museum and you're waiting, you go up to a thing and you press the button and the display lights up and it plays sound, it does all this. There's a lot more to it. So that's kind of how the GPIO mostly works, is that we can control all these different devices. If I go back to that page, and there's a whole bunch of different things that we can connect. So the buzzers we were just talking about, we can connect a buzzer that goes bzz or something like that. There's some kind of water sensor. We could have a joystick. We've seen like people on the internet make their own like arcade machines. We can do potentiometer, switch channel, like temperature sensors. Thermistor, I assume that's a temperature sensor, but I don't know what all these are. I don't pretend to. Sound sensor, photo sensor. Yeah, sound sensor would be cool. I think I saw one project that was like, wait for the special knock, like something like that. And then a door opens or something, but only if you did the special knock. So that's another application, all these different things here. Temperature, humidity. I've seen a lot of weather related sensor projects. Breadboard. Breadboard is something that's needed if you need to connect a lot of things and you need to incorporate other. See here, here's one right here. Breadboard. I kind of shy away from the breadboard if I can, because it tends to overcomplicate things. Let me stop sharing for a second so you can see what this is I'm talking about. All right. So here's a breadboard, and this is like you can connect all these wires that we were just talking about. In other words, for example, the male end of the wires would go directly into the ports here. Just had one. There we go. So here's one. So in other words, before we had our female end that went right on the pin on the Pi, like such. Now we can also have a male end that would go into a breadboard, sticking that way. That's how we can build our circuits in a different manner. Now, this thing looks confusing. At least it did to me at first. And basically what happens is, so in this case, this one comes with a ribbon cable like such. Most kits kind of have something like that. If anybody gets like a Raspberry Pi kit on the internet somewhere. Basically what happens is one half of this goes over all these pins, the ribbon cable. Okay, I think I'm actually off by a pin, but it doesn't matter. And then the other half connects to this thing here. And basically what happened is we have now extended our entire GPIO pins onto this board here. And now we can connect a whole lot more because we have so many more slots. So we're limited because, again, there's only like, I don't know, like 30 pins or something. So if we want to connect a whole bunch of things, and only some of them are programmable possibly in the way that we intend to, so we have potential to just run out of ports. So this kind of extends all this, and then we can have more stuff to work with. We can connect like external power sources and do all kinds of crazy stuff. Breadboard, excellent question. Is coding hard to pick up if you are new to Raspberry Pi? I'm going to say I don't think it is, because if you, let's see, let me share my screen again, just to give you an example of what the code looks like to, let's say, Raspberry Pi, light and LED code. Most of the time, you're going to be using Python to do this, at least in most books that you find, most tutorials that you find online. And Python is a great language and it's easy to learn, I think, and at least get something going. So I'll show you how simple the code is. If this page ever comes back, let me try another one. Raspberry Pi, push button, switch example. So I'll show you example of input and example of output. Am I going to the same site? Okay. All right. So yeah, here's an example. Actually, here's an example of how the breadboard is connected. In fact, there's one picture on the internet that made it all make sense to me as soon as I saw it, which I'll try to find. But the code for this is very simple. Yeah, so so this person is using a breadboard to light an LED. It would be a lot simpler if we just use the jumper cable, then we could bypass this entire thing. You can connect you'd only need 2 wires that way. This one you need, like, there's a light in there, well, you can put a resistor in, but that's fine. All right, the code. So here's the entire code to, and actually this could probably be even simplified. A lot of these you don't really know or really need to. I mean, you need that, I guess, yeah, in this case, because he's using the sleep function and he needs, okay, like this could be in one line, and warnings can, maybe for the sake of starting, you might not even care about. But basically, to turn a light on is basically saying, okay, port number 18 set to high means on. In this case, they said, okay, then set it to low, that means turn it off. So if you just ran this code, if you just pasted it into a text file on Raspberry Pi OS, which is off right now, but pretend it's still there, then you would have a flashing LED bulb very quickly. And this could also be, you could write some more to the program to say, wait until I type the word on and then turn it on, something like that. Alternatively, we could also connect a switch at the same time, which, again, here's the breadboard example, which I think is okay. And the code for that is, okay, yeah. So basically, these, 7 or 8 lines of code are all you need to get a push button working. So in this case, there's some setup, and there's it's number 10. In this case, we're talking about port number 10, where we have the diagram earlier that had all the numbers on it. And basically, if you ran these, just these 3 plus these 5, which is actually 4 up here, every time you push that little button, I had one earlier, basically every time you push the button, it would say, on the screen, it would say button pushed. So I think it's easy to get something going. And then, of course, in this case, okay, you made the screen say button push, big deal. But that's cool. You could do other things. This could be, as I always give the example of send an email. So like, okay, if you send an email, that means you could have it. You could also set it up to then, like through some service, like ping your phone or send you a text message or something like that every time someone pushes the button. Or it could be turn a bunch of lights on and play a bunch of sounds and make something move, all kinds of different things. So I don't think it's difficult to figure out the code for it. I mean, there's going to be somewhat of a learning curve, because if you're not really exposed to code, it's going to be like, you're going to look at this and just be like, okay, what's going on? It's just magic. So it's like, okay, now make another one, make another LED work or make another push button work at the same time. Then you kind of have to think about what the code is actually doing and write your own a little bit. But there's tons of examples online, so you got that going on. That probably is good for the sensors. Yeah, so that's an example of all the different sensors that you can get, and then kind of think of new projects. But I try to hurry it a little bit. products, we kind of look at the product catalog. That's just the different Pis and all that stuff. They have a whole help section on raspberrypi.org. Maybe we'll just look and see what's on that web page very quickly. It's this. And yeah, so they have, okay, look, they have all kinds of great, yeah, using your Pi, setting up your Pi, soldering, installing the operating system environment. They have a whole, I'll just click on the first one and see what it, yeah, okay, yeah, so they kind of like all the different things we were just talking about. Yeah, yeah. So they have a whole community surrounding this and a bunch of wonderful, helpful documentation on the internet. Projects. Okay, here is something I wanted to spend a little time on, but we'll just do it quickly because I think everyone at home is probably sleeping. That's okay. Everyone on Facebook Live is sleeping. Okay, so here are some excellent possibilities for Raspberry Pi. So, okay, that's some kind of tutorial. So room temperature monitoring, you can see this person connected a Raspberry Pi to a breadboard and a sensor, and it looks like some kind of little LED display. So it displays the temperature and the humidity all the time. Okay, great. Kind of maybe even, I think there's more interesting things that we can do. Here, someone made some code to, I think, attach a camera, and then probably the camera is sitting on a Raspberry Pi, which is sitting in a window and looking at traffic, and I guess counting cars, I would think. Looks like he's counting the number of cars. It's actually kind of interesting. I think there's a better list of projects. Perhaps it's this one. This would be someone asking about the potential of what can you do with Raspberry Pi. There we go. Okay, weather station. Cool. We kind of talked about we just sit outside somewhere and detect the weather. Twitter bot. Okay. I don't know. You could program your Raspberry Pi to send tweets out. Print server. Okay. Apparently, you can make a. You can pick up radio stations with Pi. I didn't know that. That's cool. Tor router. File server, okay, network monitoring tool. Here's an example of somebody connected an LED screen to their Pi. You can see the Pi is in the background. It's in an enclosure along with some kind of screen. And this person is measuring what I presume to be his internet latency. Kind of cool. Minecraft application, I think is mostly uninteresting. Time-lapse camera is cool. In fact, I did that recently with a Pi0, which is maybe interesting, maybe not, but basically it's a Pi0 on the inside, which is like the smaller, the really, really small version of this. These are the ones that are like $5 or $10 if you get the wireless built into it. And it has the camera attached to it. Basically, what I did with this was run a couple pieces of code and turn it on and tape it to a tripod, and it looked out the window for like 2 weeks at some mushrooms that were growing outside the library. And later I just took all the images and made like a time-lapse video out of it. And we did another one with bags of mushroom spores inside the library where we just we just ran some code on it, plugged it in. It took like a picture every 5 minutes for like a week. And then a week later, when everything had done what it was supposed to, either grown or done whatever, we were able to capture all the images and make a time-lapse video out of it, which is sort of cool. It's time-lapse and VPN server. Okay. Motion capture security system. Okay. That's pretty cool. We've already kind of shown that you can connect a camera to the Raspberry Pi. So you can take pictures with it. You could program it to take pictures at a certain interval, or you can say capture video all the time. And by extension, then he's saying, okay, if you're capturing video all the time, you can run another piece of code that someone else has already made, so you don't have to write anything other than implement it. You can say, when you detect motion, do something. So this could be, okay, when you detect motion, start recording. So because I want to know what happened, like a security camera system. Or again, like when you detect motion, then send me an email and then have a phone, ping my phone. It's like a Ring doorbell. Everybody's seen Ring, where it's basically they have a camera on their door, and when somebody, the delivery guy comes up and rings the doorbell, if they're at work, they get a ping on their phone and they can see the video, and it's great. Well, Raspberry Pi could probably do that. In fact, apparently someone has already had that idea and already made it work. So that's another application with the camera. There's probably a whole bunch of different camera applications that could be made. AI assistant, looks like somebody made the Raspberry Pi listen to their voice with a microphone and say, I guess when you go in and things on and you say, just like Alexa or something, you go into somebody's house and you say, Alexa, play Michael Jackson on the radio. And then the radio starts playing and Michael Jackson. Apparently someone has already took that idea and made the same thing happen with Raspberry Pi. Great. Media center. So that's, if you have a library of a bunch of media that you want to play on your computer, you can put some software on there to connect the Pi to your television, and you can even stream media on it as well. Distance sensor, that's interesting. That is, I guess, sort of like the, you see those guys at construction sites and they have like the laser sensor, and they're trying to gauge a distance. They need to know how far it is from A to B, and they go on. Apparently you can create your own with what I presume is just emitting light and waiting for something to become reflected back and then measuring the distance. That's kind of cool. Again, see with the breadboards, it gets a little crazy. Like, look at all those wires. So you'd have to, if you're going to do that project, you'd have to pay very close attention to what's happening, follow the guide exactly, I guess. Wi-Fi extender, okay, sure. Wi-Fi Twitch is video game streaming. Virtual gaming machine is, again, I think that's something that's popular with Raspberry Pi. In this case, somebody, not sure which model of Pi is actually underneath here. Basically, the person probably has the board underneath and then an LED screen on top of it, all in an enclosure, and connected again, a couple of, push button switches along with a joystick, and that's all connected, and then probably running like an old video game, like Space Invaders, like this person is doing. So that's kind of cool. Smart TV. Okay, we kind of talked about connecting to your TV already. And all of these have, links. Home automation system. Yeah, so again, another application is people, they get an app on their phone where they can control their lights and their drapes and the temperature on their thermostat and things like that. I could probably be programmed to do the same thing. I say probably would be probably almost definitely, because it looks like someone has already done it, and there's a link to how to do it. Full-fledged computer. Kind of talked about that already when we load at least the base operating system on it. You could use that as a computer, but you're using in the case of Pi Zero, you could run it as a computer. There's a whole interface, like a graphic interface, like when you load up Windows and you get the start menu, all that stuff. Well, Raspberry Pi OS has a similar thing that's Linux-based, but it basically is the same idea. So you could run it as a full computer, but again, you got to remember that if this costs $5, you're basically running a $5 computer. So it's not going to be the fastest thing on the planet. Probably wouldn't recommend it for, checking your email and watching YouTube and stuff like that, although it could, but probably not recommended. Oh, and then this whole comment section with some other ideas. And I'm just going to go over, I don't think I have a whole lot more in this. I really don't. Look at one more page of ideas, not go over every single one, promise. And let's see, 25 cool Raspberry Pi projects, media server, weather station, parent detector. I don't know how that one works. Okay, yeah, that's another example of motion detection with a camera. Radio, Minecraft server, temperature log, retro gaming console, a lot of the same ones. Desktop, app server is basically website, laser tripwire, time-lapse camera, music box, program your Pi to play music, probably extension of the kind of Alexa example that we had earlier. Home monitoring again. Gesture controls, that would be interesting. Looking at that one. Control LEDs with your voice. That's interesting. It's like the clapper. Well, again, if everyone remembers that. Lights turn on. Yeah, I'm sure there's a lot more. More interesting ideas, and these are just a couple ideas that people have come up. Oh, yeah, come back to that later. So, yeah. So here's some ideas that we've kind of done around here. So obviously, RetroPie is the one that's popular. That's just like the old video game thing. That's kind of uninteresting, I think, at this point. Media streaming, I think, is also kind of uninteresting. So the cameras, again, you can connect the camera to it. You can do examples we use for security camera and time lapse and motion detection. So those are some ideas that can be done with the camera. Web server is it's kind of uninteresting. Basically, you could run software on here to have it run a website, and then you could have your website running, in the corner of your house or something, and it would just be there. Buzzer game systems. Yeah, one time we did sort of like a quiz bowl buzzer system where it was like whoever clicked their button first was the person that got to answer the question. It was just kind of an exercise in making a buzzer system. Photo booth, of course, is another one that's pretty cool. I have it over there, but I don't want to hook up the whole thing. But basically, I think that's cool. That's probably the coolest one that I think I've done. Basically, it's a Raspberry Pi connected to a monitor, and we walk over there quickly. I think. Yeah, there we go. Here it is here. So here's an application. Oops, let me stop sharing for a second. A real life application, which is basically that of a Raspberry Pi attached to a big monitor. There's a camera on the top of it, and there's a big button. Here's another example of a button. It sits there and it waits, and when someone goes up and pushes the button, the thing shows what the camera sees and takes 4 pictures in a row, and then it sends it to a printer and prints it out for you. I think it's cool. It's kind of like when you go to a wedding or something, they have the photo booth thing, and it costs like $1,000 to have them there for like an hour. You could just make your own. Somewhat simple. Back to the screen. Kiosks, yeah. If you go to the library here, you'll notice a lot of, at least a handful of television screens that show slides about our newest programs at the library and upcoming things, days closed, things happening at the library. Basically, those are Raspberry Pi Zeros, like a $5, $10 piece of equipment that just shows a bunch of slides every so many seconds. Easy application. Audio announcements. If anyone remembers when the library was first closed for COVID and we first opened back up, there was a little voice that came on because we have timed appointments. There's a voice that came on like every half hour that said, your session is ending in 5 minutes or something like that. Again, that was a Pi attached to our overhead speaker system, PA system, that just ran some code to say every so many minutes at the top of the hour and at the bottom of the hour, play a certain message over the intercom. It's easy. So we don't have to have somebody like waiting with their watch trying to make 48 announcements every day. Time lapse, I already talked about. Some other ideas. So the weather sensor, which we kind of saw, I would like to get there's some examples on the internet, people like controlling a robot with Raspberry Pi. And I think that is interesting to me. I think it would be kind of like, instead of connecting an LED, I think it would be something sort of like connecting a bunch of DC motors. I don't know if you can see this. This is just a motor. Basically, when it becomes powered, in other words, when we, it's in the other example, when we turn the LED light on, the light turned on, we power this thing spins really fast. They could drive like a wheel or something, or an arm or something with our robot. I think could be another project that we might do. Another sensor, Magic 8 Ball. That was another example. It's just kind of, I don't know, basically have a handheld device that gives you a random fortune every time you touch it. iHole is it's a DNS blacklisting thing that's not really interesting to most people. Wiimote, I did have some success connecting a Wiimote. Anybody doesn't know what a Wiimote is? Nintendo Wii, it has the Bluetooth sensor, controller, I should say. You can connect that to Raspberry Pi. So instead of having a tactile push button physically attached to Raspberry Pi, you could take the Wiimote, which is Bluetooth, and have that act as input. Basically means you could have a wireless controller for something. In the case of a robot, that could be, I push the A button or the B button, make a different wheel move, or we could extension to make our own robot. Door counter is one that I haven't done that I want to do because it should be easy to say, have the laser wire whenever it gets interrupted, increment the counter, and then have some kind of stats for who walked in and out of a room, how many people came into the library on a certain day. Or, you know, if you're at home, like who walked into your room, what time were they there, what time did somebody open the refrigerator door, something like that. Yeah, we have books. I have a couple on the tables here, but nobody showed up in person. So they'll just have to, you all have to take my word for it that I pulled 5 or 6 books from our collection. We do have a number of books on our catalog. In this case, I'm just searching our library catalog for the word raspberry. Hopefully there's not too many books on raspberries and more on Raspberry Pis. So we've got all these books here. Actually, maybe just books and not ebooks. Raspberry Pi cookbook is right over on the table next to me. This one's on the table next to me. Step-by-step guide to beginners. There's a book on actual raspberries. Getting started with Python. That's the programming language that we could probably use. Here's a projects workbook. Manage computing. Yeah, so we have a bunch of books, and these are just the books that we have in the library. There's a kid's book for Raspberry Pi. So we have these books in the library right now for anybody that wants to come and check them out. We also, as you know, we're part of the SWAN library system, so we have access to 120, something like that, different libraries. So if there's a book at Oak Park Library that is really good that you want, we can just order it and it'll be here in like 2 days and then you can check it out. So yeah, that's good. And that was pretty much all I had planned for today. So at that time, I would open up to questions and answers in this room full of no one but me. I'm glad that someone online has joined. There was another person here too, but I think I bored him to death. So I appreciate your questions that you had typed in the chat. Again, my name is Mike. I work at the library here. I'm usually downstairs, and that is the Raspberry Pi. Here's kind of all the equipment that I was trying to get to talk about. And I might as well show the books. Here are some of the books that we have at the library. I think there's actually a couple more upstairs in the youth department. And that, I think, will do it for now. Yeah, it's 7-Eleven. So thank you for your time. Thank you for joining everyone on Facebook that will maybe see this at some point in their life. My name is Mike, and that's it. Thanks. Have a good day.